Hi everyone, welcome to our next video lesson. We're on section 7-8. We're talking about inverse functions and inverse relations. So in this first one, a relation is just a set of ordered pairs. So we have three ordered pairs right here. That's what a relation is. Now the inverse relation is also a set of ordered pairs, but the way we get it is by reversing the coordinates of our x's and y's. So notice how this was 3, 7. I'm going to reverse the order, and now it's going to be 7, 3. 2, 6 becomes 6, 2. 0, 4 becomes 4, 0. So to find the inverse of a relation, all you got to do is change around the x and y ordered pairs. Quite simple. Notice what that looks like on a graph. Here we have the relation 1, 3, 6, 3, 6, 0, 1, 0. Find the inverse of the relation. Well, that's quite simple. Bring 1 right here, bring 3 right here. So our inverse relation is 3, 1, 3, 6, changing around the ordered pairs, 0, 6, and the last one is 0, 1. Next part says plot the points of the relation with the dots and the inverse relation with the x's. So we're going to see what this looks like when we put it on a grid. So let's put this, it tells us to put the relation with dots. So let's plot these points with dots. Go right 1 up 3, put a point. Go right 6 up 3. Right 6 up 0, and right 1 up 0. So we have those 4 points for our relation. Now it says let's plot the inverse with x's. The inverse relation, plot it with x's. So 3, 1 is going to be our first point. Go right 1, 2, 3 up 1. Oopsie, x's. The next one is right 3 up 6. Right there. And then we have 0, 6 and 0, 1. Okay, so the red dots is my relation, and the green x's is the inverse of that relation. Now it tells us to graph the line y equals x, and what do you notice? You're going to get very, very good at graphing the line y equals x. But just to refresh you, it's y equals 1x plus 0 would be another way to write it in mx plus b form. So it has a y-intercept of 0. And then it has a slope of 1, so it's a rise of 1 and a run of 1. Up 1 over 1, up 1 over 1. So my line looks like this. If you had a straight edge, I would encourage you to get that. And here is our line. The line y equals x. Now the last question on this here, it says, what do you notice? I want you to pause the video class, and I just want you to think about what you notice about the green x's and the red dots. After you've thought about it for a little bit, here's what you should see, is that they are symmetrical over the line y equals x. Or another way of saying that is they are reflections of each other. The relations are reflections of each other over the line y equals x. So here's what I mean by that, class. Let's say this was a piece of paper, your grid was a piece of paper, and what if you were to fold the paper on top of the blue line? So the blue line is like the fold. Wouldn't this dot right here and this x land right on top of each other when you fold the paper? Same thing with this x and this dot. Same thing with this dot and this x, and the same thing with this dot and this x. They are all the same distance away from the line y equals x. So if you fold the paper, boom, the red dot would land right on top of the green x. That's what is called symmetry, or what we call a reflection. So the reflection line is the line y equals x, and then our reflection points are the relation and the inverse relation. And this is going to be a common theme in this lesson. Let's now try it with a line. So now we're talking about inverse functions and not so much relations. So a function has to pass the vertical line test. And so the inverse of that function is often called f to the negative 1 of x. We never say f to the negative 1 of x. We always call this the inverse function of x. That's how it's written. Or that's how it's read, rather. To find the inverse function, all we got to do is switch around y and x. And then we got to solve for y. So to find the inverse of any function, to find the inverse of any relation, just switch around x and y. Now to find the inverse of any function, All we got to do is switch around x and y and then solve for y. Let's practice that. Remember, whenever you see f of x, it's the same thing as writing y. So make sure we make that known. Here we have this one. Here is our function. It's y equals a negative x plus 2 divided by 2. Now, when we graph this, we usually divide each term by 2. So if that was the case, we'd have a negative 1 divided by 2x plus 2 divided by 2, which is 1. So that's how we would write this one usually. Y equals a negative 1/2 x plus 1. Let's graph and label that. So here's how we're going to graph it. It has a y-intercept of 1, and our slope is up 1 over, our slope is down 1 over 2. Negative 1/2. So down 1 over 2, down 1 over 2, down 1 over 2, which is left 2 up 1, left 2 up 1, so on and so forth. Here is our line. Now class, this is our function, so we're going to label this, and we're going to call it f of x. So make sure you label it accordingly. I will dock you on your test if you do not label. So that's the function of x. Now we're going to find the inverse function of x, which is right here. To find the inverse function of x, all you got to do is bring y over here and bring x over here. You're just switching around x and y. So now x equals a negative 1/2 y plus 1. And now we need to solve for y. When we graph lines, we got to get it in y equals mx plus b form. So let's first subtract our 1. So now I'm gonna have my y's on the left side. So it's going to be a negative 1/2 y equals x minus 1. Hopefully that didn't confuse anybody. All I did was just switch around, put the x's to the right and put the y's to the left. Now to get y all by itself, I'm going to divide by a negative 1/2. Dividing is the same thing as multiplying by the reciprocal, so it's really multiplying by a negative 2 over 1. So my inverse function of x, equals a negative 2x and a positive 2. A negative 2x and a positive 2. So my y-intercept is right here. It's at a positive 2. And then my slope is down 2 over 1. Down 2 over 1. Down 2 over 1. So on and so forth. Which is left 1 up 2. And there's my line. We'll graph this, and it's best to use a straight edge, so I encourage you to use a straight edge as you have your notes. Let's label this. This is the inverse function of x. So the f to the negative 1 of x, read as the inverse function of x. So we've done letter A, B, and C. Letter D, it says graph and label the line y equals x. Well, as we found from the last one, the line y equals x, it starts at the origin, and then it goes up 1 over 1, up 1 over 1, up 1 over 1. There's the line y equals x. Okay, what do you notice about the function and the inverse of that function? Hopefully, once again, you notice the exact same thing from the last problem. If you were to fold the piece of paper on top of the line y equals x, so the line y equals x is the fold in your paper. Let's label that line y equals x. Wouldn't the green and the red land right on top of each other? That's called a reflection. Okay, the two lines are reflections of each other. That's what we notice for letter D. The two lines are reflections of each other. And that's what we get for that one. Why don't you guys pause the video and you guys try the last one on your own. Okay, so when you graph this one, you get a y-intercept of 5. 1, 2, 3, 4, 5. And then the slope is 4 over 1. So it's a rise of 4 and a run of 1. That goes off my paper, so if I go up 4 over 1, that's the same thing as going left 1, down 4. Left 1, down 1, 2, 3, 4. Left 1, down 1, 2, 3, 4. And left 1, down 1, 2, 3, 4, roughly. So here is my line for my function, f of x. That's what you should get for letter A. Now it says find the inverse function of x. So if this is y, we're now going to switch around x and y. So it's going to be x equals 4y plus 5. Let's now solve for y. Subtract 5 from both sides. I get 4y equals x minus 5. Divide both sides by 4. Y equals 1/4 x minus 5/4. X equals 1/4 x minus 5/4. And that's your inverse function of x. So instead of calling it y, we should label it accordingly as the inverse function of x. Okay, so let's graph this. Let's go down 5/4. So a -1 and 1/4 is a -5/4, roughly about right there. And then my slope is up 1 over 4. Rise of 1, run of 1, 2, 3, 4. Roughly right there. Which is the same thing as going left 4, down 1, left 1, 2, 3, 4, down 1. And there is your inverse function. So now when we're looking at this one, letter C says, oh, we did letter C. Letter D says graph the line y equals x. So, as we've done in every problem, it goes at a 45-degree angle from the origin up and to the right. What do you notice about these two lines? Once again, they are reflections of each other. If you were to fold on the black line, line y equals x, which we should label, we notice that the two lines, the red and the green, are reflections of each other. And that's how all inverse functions work, class, of each other. That's how all inverse functions work. You could always check your work on this one, because if you have a mental check of folding it along the line y equals x, the two lines should always land on top of each other. That's how you know whether you did it right or wrong. Let me know if you have any questions on that when you get to class tomorrow.